So basically when you have two linear equations with two variables, you can plot those equations on a graph. A linear equation is nothing but a straight line, and a linear equation in two variables can be plotted on a xy plane. So the same problem that we have just seen with the cost of the individual pencils and the books can be solved graphically as follows. So first we will begin with the equations, which are 3x plus 2y equal to 80 and 4x plus 3y is equal to 110, as you have seen previously. So then we start putting some values for x, and then we'll calculate the corresponding values for y in both the cases. So these will be our points on the straight line that we are going to plot. So the same equation here can be expressed as y is equal to 80 minus 3x by 2, and this equation can be written as 110 minus 4x by 3. So that is your y. So let's put some values for x. So I'll start with 0, 5, 10, 15, 20 and 25, and then we'll calculate the corresponding values for y. So when x is 0, so 3x is 0, so 80 by 2 becomes 40. When x is 5, so 3x is 15, so 80 minus 15 is 65, 65 by 2 is 32.5. Similarly, you can calculate the other values. Same thing here, when x is 0, you will have y is 110 by 3, which is 36.67. When x is 5, y is 110 minus 4 times 5, 4 times 5 is 20, so 110 minus 20 is 90, 90 divided by 3 is 30, so that is 30. Similarly, you can calculate the other values as you see here. So the next step is to point these values on a graph. So the first equation, as you see, has been plotted in the green, and the second equation is plotted in the yellow color. So the solution to these two equations is the point at which these two lines intersect. So as you observe here, this is the point where these two lines intersect, and that point can be expressed as the x coordinate is 20 and the y coordinate is 10. At 20, 10, these two lines intersect. So we can say that the cost of the pencil, which is x, is 20 rupees, and the cost of the book, which is y, is equal to 10 rupees. So also from the table you will see that these are the two values which are common in both the cases, 20 and 10. So the point which is common to both the equations is the solution to this linear equations with two variables. So this is how you calculate the linear equation in two variables in a graphical method. So typically, let's assume the general equation, which is a1x plus b1y plus c1 equal to 0. Let that be the first equation. Then a2x plus b2y plus c2 equal to 0 be the second equation. So there are three possibilities in which these two lines can look on a graph. Either these two will be parallel lines, like as you see here, or they will be intersecting lines, and two straight lines can intersect only at one point. Or they can be lines which are coinciding. So basically one line lies exactly on the other line. So in this case there are many solutions which satisfy both the equations. So here we have infinite number of solutions in the third case, whereas here there is only one point which satisfies both the equations. Over here there is no solution because these two lines never intersect, and there is no solution that satisfies this type of equations. So now let's try to find the relationships between these two lines, that is whether they are parallel lines, intersecting lines or coinciding lines, by looking at the coefficients of these two equations. So let's start by looking at some examples. So we have 3x plus 2y minus 80 equal to 0 and 4x plus 3y minus 110 equal to 0. So we'll begin by looking at the coefficients, which are nothing but a1 by a2 here, b1 by b2 and c1 by c2. So now let's try to calculate these values for these equations here. So in the first case, a1 by a2 is 3 by 4, right? 3 and 4, whereas b1 by b2 is 2 by 3, and c1 by c2 is minus 80 by minus 110, so which is nothing but 8 by 11. So as you observe here, a1 by a2 is not equal to B1 by B2, which is not equal to C1 by C2. So in general, if A1 by A2 is not equal to B1 by B2, then we call these two lines as intersecting lines, which will have a unique solution. Now let's look at the next example. So A1 by A2 here is 2 by 4, which is nothing but 1 by 2. B1 by B2 is 3 by 6, which is nothing but 1 by 2. And C1 by C2 is minus 4 by minus 8, which is nothing but 1 by 2. So in this case, you observe that A1 by A2 is equal to B1 by B2 is equal to C1 by C2. These are the lines where you will have infinite solutions because these two lines overlap each other. Let's look at the last scenario over here. So A1 by A2 is 1 by 2. B1 by B2 is 5 by 10, which is nothing but 1 by 2. And C1 by C2 is minus 1 by minus 5, which is nothing but 1 by 5. So in this case, A1 by A2 is equal to B1 by B2, which is not equal to C1 by C2. This is an example of parallel lines, and these lines will not have any solution in common. So as we have seen here, the relationships are A1 by A2 is not equal to B1 by B2. In the second scenario, we have A1 by A2 is equal to B1 by B2 is equal to C1 by C2. The last scenario, we have A1 by A2 is equal to B1 by B2 and not equal to C1 by C2. So these are the relationships of the coefficients which will help us determine whether two linear equations with two variables have unique solution, infinite solutions, or no solution. Let's look at another example. 5 pens and 7 pencils cost 50 rupees. 7 pens and 5 pencils cost 46 rupees. Find the cost of 1 pen and 1 pencil. So again, this is similar to the book and pencil example that we have seen before. So the equations of these two are, so we have 5x plus 7y is equal to 50 rupees. That is your first equation, assuming x is the cost of the pen and y is the cost of the pencil. And the second one, we have 7x plus 5y is equal to 46. So here we have 7 pens and 5 pencils which cost together as 46 rupees. So again, as previously, we can express the first equation as y equal to 50 minus 5x by 7, and the second equation as 46 minus 7x by 5. So we take some values for x and then calculate the corresponding values for y. So as you see here, I have calculated those values and I have plotted them on a graph, and the place at which these two lines intersect is 3, 5. Right, this is the point which is 3 and this is 5. As you have seen here, this intersects somewhere here, which is 5. So 3 and 5. So the solution to these two equations is 3 and 5, which means that the cost of the pen is 3 rupees and the cost of the pencil is 5 rupees. And also, if you observe, these are the values which are common in both the cases, 3 and 5. So this point satisfies both the equations. So this is how you solve linear equations using the graphical method.